Lesson 6.5 is about solving open sentences involving absolute value. I'm breaking it up into two parts because there's two distinct things in the lesson. Today we're going to look at solving absolute value equations, and in the next part we'll look at solving absolute value inequalities. There are three types of open sentences that can involve absolute value. The absolute value of x equals n. It could be absolute value of x could be less than n, or the absolute value of x could be greater than n. Now remember, absolute value actually means distance. So if we look at the case of absolute value of x equals n, or in this case the absolute value of x equals 5, it means the distance between 0 and x is 5 units. So we could either go 5 units to the right and be at positive 5, or 5 units to the left and be at negative 5. So if the absolute value of x equals 5, x equals either negative 5 or 5, so the solution set is negative 5 or 5. So saying the same thing in words, when solving equations that involve absolute value, there are two cases to consider. Either case 1, the value inside the absolute value symbol was originally positive, or case 2, the value inside the absolute value symbols was negative. I'm going to show you two ways of solving example 1, graphically and algebraically. So they gave us the absolute value of b plus 6 equals 5. So to get our plus 6 back to 0, we'd have to subtract 6. So this graph is going to be centered around negative 6. And then we will move 5 units to the right. We get a negative 1. 5 units to the left, we're at negative 11. Now, some of us aren't crazy about always drawing out a number line for everything we do, and sometimes the algebra will get a little complicated to do on a graph. So then we're going to use our case 1, case 2 strategy. So case 1, we just drop off the absolute value sign and don't change anything because what was inside the absolute value was positive. Case 2, I'm going to drop off the absolute value again, but this time I'm going, hey, the stuff inside was negative, so I changed that sign to negative 5. Now the solving is the easy part. Subtract 6 from both sides. I have b equals negative 1, which was one of my answers graphically. Subtract 6 from both sides, and I get b equals negative 11, which was my other answer when I solved graphically. Two methods, same answers. Okay, now we're working from the other direction, writing an equation involving absolute value for the graph. So I want to find what the middle of that is and see how much I have to go either side to get to it. So if I add negative 4 plus 6 and divide by 2, I get 2 divided by 2 is 1, should be my center. And I would have to go 5 units to the right or 5 units to the left to get to my 2 points, which their graph shows nicely. So I'm centered around 1, so my expression is going to be the absolute value of x minus 1 equals, I went 5 units on either side of it. Now I can double check that by substituting my numbers back in there. If I do the absolute value of negative 4 minus 1, absolute value of negative 5 is 5. And if I do the absolute value of 6 minus 1, absolute value of positive 5 is also 5. So I know I have the right answers, and that's my answer. So far, we've just done the absolute value for equals. So our graph only has 2 points on it. If the absolute value of x equals n, then x equals either positive n or negative n. So we're going n units to the right or n units to the left. Now in the next lesson, we're going to look at the less than. So in our less than graphs, it comes together because we have fewer than n units away from our center. In a greater than graph, our arrows are going to go out because we have more than n units from our center.